Well, hello friends. Welcome back to another Commute Talk. Today it's time for another little WebKit story, but we're not going to be dabbing on anyone today. Just thought I would talk about an interesting thing that I worked on at one point. So, we used to have this problem that we would get bug reports coming in for the Safari browser on desktop, the macOS Safari, that someone would have like a Safari tab which was using up all of their system memory, and Mac OS, or OS 10 as it was called back then, but Mac OS was really shit at handling situations where you would just use up all the system memory. It's not like iOS. I mean, I don't know, maybe this has changed by now because I haven't actually kept up with macOS internals, but it wasn't like iOS where there's like the system mechanism called jetsam, which will just kill any process that goes over a certain predetermined memory limit. Because on macOS you were just allowed to keep going, and like the system, you would keep allocating and the system would start giving you swap memory, or I mean, first you would do the memory compression stuff and then it would start giving you swap, and you could just keep going like that and make yourself gigantic and grind the system to a halt, basically make it completely unusable. And yeah, so we used to get bug reports about that, like, hey, my Safari tab is using 12 gigs of memory in my 8 gig machine, and everything is just terrible and I can't use my system. And it's not that we got these like by the hundreds, but we got enough of them to worry about it. So I spent a considerable amount of time just trying to work out like what the hell is happening. We added all this logging to try to work out like why were these tabs getting so big. Found many bugs that would cause a tab to leak over time. We fixed so many little issues and like garbage collector marking, things that would, like, you could do things in JavaScript that would end up accumulating objects and never destroying them. All these interesting interactions between C++ and JavaScript that we had to fix. But we the most important thing that we did was putting in telemetry to learn just how many people were affected and like how bad was it, what kind of memory numbers were we actually seeing on people's systems, and what we learned from that. I mean, I know that telemetry gets a bad rap, but I really think that if you anonymize your telemetry data, like Apple does, I know that they do, because I've been like on the receiving end of Apple telemetry, and it is like anonymized to the point where it's irritating. Like it's annoying that you can't get more information from it. Like very often you're just sitting there like, here's the top level domain of a page that's crashing. Thank you. That's great. Like, you really wish that you could have the URL. But they would just give you the top level domain, stuff like that. Anyways, so we started getting this telemetry data, and it was very granular. It was like, we had this many percent of the user base had a tab that was using more than 1 gigabyte of memory in the last 24 hours, something like that. I don't remember exactly, but it was like extremely anonymous information, basically, across millions of users. And the thing was that we discovered that there were very few people, percentage-wise, who were having this issue. It's just that I guess there are these types of issues that are so freaking bad that when you hit them, you definitely report a bug. Whereas, like, if you run into some annoyance every now and then, you can sort of work around it and you just learn to live with it. But this was this type of bug that just prompted people to report it when it happened. And I totally understand, because it happened to me many times during testing, and it was really bad. So we got all this telemetry data, right? And we saw that the thing that I was not expecting to learn, because we were just trying to find out like how bad is the problem, but it also ended up teaching us how big are tabs normally. And we learned that like the vast majority of tabs are never ever bigger than a gigabyte, right? Most of them smaller than 500, most of them smaller than 400, and then we start to have some variance. But over a gigabyte, that was like suspicious territory, very suspicious. And 2 gigabytes, that was like, no, you should not have a browser tab that's above 2 gigabytes. So we came up with this idea that what if we just, instead of letting the system, bloat itself over time, why don't we just suicide these tabs when they go over some suspicious number? And that's what we ended up doing. So I implemented this because at the time there was this like almost rumor that macOS was going to get something like jetsam, like iOS jetsam in the upcoming release. There was like a macOS jetsam project at one point, but then it kind of fizzled out, and I don't know what became of it. Maybe today it's in place. If so, I'm really happy for you, because jetsam it's a really good idea. Anyway, we didn't get jetsam on macOS in that release, so I ended up making a WebKit jetsam. It was called websam, and basically it's like this little thing that periodically checks the resource usage of each individual tab process. So it looks at memory usage, CPU usage, stuff like that. And then I don't remember how often, maybe it's every minute or every 30 seconds, I don't recall. Anyways, it gathers that data and then sends out this little anonymized telemetry about it. I mean, it doesn't send it out every minute, but it accumulates it, and then it gets sent at some coalesced point in time in the future where we have a whole bunch of data to send. The thing was that, so if we crossed over I think it was the 2 gigabyte, if we crossed over the 1 gigabyte mark, we had these like 3 levels, I think. There was like the warning level and the critical level. And first you just cross into the warning level, and at that point, we would put you on like special probation mode or whatever. Like that tab process would be in a special probation mode where we would limit its ability to use caches. We would sort of degrade the performance of the tab a little bit to sacrifice its memory usage. So like we wouldn't do aggressive tiling of the page, stuff like that. And you could kind of tell when a tab was in this mode, because if you would scroll the tab very quickly, then you would sort of see these little painting glitches at the bottom of the window, because it would like we wouldn't have the whole page cached, so we would like have to paint it as we go. Anyways, it was not a great experience, but it did alleviate that situation, and in many cases it ended up saving the day when you had a tab that was like was about to steer into dangerous territory, but because of this mechanism we were able to like shrink it down and get it to a more reasonable number. But then we had these tabs that were just clearly leaking objects, right? And like no amount of restriction was going to help, because they were just leaking because of bugs. And instead of trying to fix those bugs, we still tried to fix them, but instead of trying to fix them while they were happening, we just said like, all right, well, just die. And we put this out in an alpha release, I guess. I don't remember what we called them. It was in a developer beta, I guess, actually, at WWDC. One of the I don't remember what year this was, but I think the first developer preview build that we had when WWDC had this mechanism, and it was too aggressive. So people ended up seeing a lot of killed tabs. So what we ended up doing was we decided that if a tab is a foreground tab in the window, probably I care enough about it that it would really annoy me if this tab just disappears. So I think for the foreground tab, we raised the number to some like really high number, like 8 gigabytes or something like that, or maybe it was 4 gigabytes, but like some really high, unreasonably high number. And then we kept the lower numbers, the lower thresholds for killing for background tabs, so that any tab that was not a foreground tab, it could get zapped if it started leaking memory in the background. And the foreground tab, we would let it go for a little longer, but eventually we would kill that too. And we were, I was tinkering. Me and my manager, Gavin, we were tinkering with these numbers back and forth throughout the beta. And I don't remember exactly what numbers we settled on, but as far as I know, once that release went out, we did not get any more of those. My system has ground to a halt because of Safari memory usage bugs. I don't remember seeing one after that. And I was really happy about that, because that was a shitty bug. And I remember, so what did I learn in this story? Well, one thing was, I remember very clearly feeling annoyed at the time that, like, well, this is so inelegant. Like, we're just papering over the problem. Instead, we should be tracking down what is the memory leak. And this was like, I don't know what kind of thinking you would call that. Like, it was like this sort of tunnel vision engineer thinking that, like, oh, we should just figure out what the problem is and solve it. And then Gavin would ask, well, like, what if we can't solve it? Or what if we don't find it in time and we have to make a release? And he always had this great way of, like, taking my stupid, like, engineering tunnel vision and just, like, nudging me back into the product way of thinking. I love Gavin. He was just a fantastic manager. And so he always just somehow got me back to thinking clearly about this type of stuff. And that's how we ended up doing like the solution, where we would just, if we can't solve the problem, we'll just kill the process, and like the user will be a bit annoyed, but definitely less annoyed than he would be if his whole machine grinds to a halt and he has to power cycle it. And now in retrospect, it's so obvious that Gavin was right about all of this. And it's strange I can recall very vividly how I felt at the time that, like, oh, but this is so stupid, like, we should figure out the bug, and we should just do analysis and blah blah blah, and maybe add more logging, we'll figure it out. That was silly. And I'm really happy that we ended up doing that, because we fixed like a class of bugs basically that disappeared. At least I hope they did. I didn't hear about them afterwards. So that was good. I guess that was the whole little story about that. So thank you for listening, and for hanging out with me on the commute here. I hope you all have a good day wherever you are, and I'll see you next time.